Okay, so with this one, I'm going to look at these two numbers, find the prime factorization of them, and find the GCF. So the GCF in this case is going to be the number that goes into both of these numbers, but the biggest number that goes into both of these numbers. So right now we'll just start with 2's. Does a 2 go into both of these numbers? Are they even? So yes, they are even, so 2 goes into them. 2 goes into this one 9 times. 2 goes into this one 15 times. Okay? Does a 2 go into both of these numbers? No. Okay? So what does? Well, let's look at 3. 3 does, because 3 goes into 9. And 1 plus 5 is 6, which is divisible by 3. So I know 3 goes into both of these. Okay, how many times? 3. How many times? 5. Does any number go into 3 and 5?
1.
1, good. So the only number that goes into both of those is a 1. Okay? So now I know that my GCF is the numbers that are listed on the side. In other words, 2 times 3, which in this case equals 6. So the biggest number that goes into 18 and 30 is 6. Does that make sense? Okay. But what's the lowest number that both 18 and 30 both go into? So I know that 18 goes into 36, but does 30? No, right? Well, what else does 18 go into? Well, if you add another 18 to 36, and you add another 18, see, you can kind of look at it that way, or we can remember our pattern that we developed, okay? Our pattern said, hey, if I take this L, then I created my LCM. Okay? Which means I take 2 times 3 times 3 times 5, or 2 times 3 squared times 5. Well, in that case, what is 2 times 3 squared times 5? Well, that's 2 times 9 times 5, or 18 times 5, which is, again, 5 times 10 is 50, and 5 times 8 is 40, so they equal 90. So my LCM is 90. Okay? Now, that's great. The LCM is 90, the GCF is 6. But what does that matter? Well, the thing is, it matters when you have a problem like this. When you have a problem like, I don't know, 5 over 18 plus 23 over 30. Okay? Now, with 5 over 18 plus 23 over 30, now I need to find out what the lowest common denominator is, because I can't add the fractions if the denominators aren't the same. Well, we know that the LCD and the LCM are the same thing. So by figuring out that our LCM was equal to 90, then I know that what I want here are 2 fractions that equal 90. Well, if I look at this, what's nice here is I got this 18 and this 30, right? And I did the math, and I said, well, I said that 3 went into here, oh wait, first 2 went into there 9 and 15 times. And then 3 went into there 3 and 5 times, right? So the thing is, what I know here is that these numbers right here represent 18. And these numbers right here represent 30. Okay? Well, what's really cool about that is it tells me right away what times 18 is 90. Because if the LCM is all of these, right, then whatever's not in the blue is times the red. Whatever's in the red is times the blue, and whatever's in the blue is times the red. Okay, that isn't already in them. So what's in all of them? So it's kind of like a Venn diagram here. What's in all of them? Well, the GCF's in both of them, right? The GCF, in this case, is 6. Right? And that's in both of them. But what isn't in both of them, in one of them, is the 3. So let's do that in blue. So that's going to be 6 times 3, which is 18, right?
Yeah.
Okay, well that's 18. And then 18 times what is going to be 90? It's going to be the 5 that's left over. So this 5 is how I'm going to manipulate the fraction into being a fraction that we can add. So now I've got 5 times 5, which is 25, over 90. And that's the same as 5/18, except now it's over 90. Okay? And then I've got the red, which is 2 times 3, or 6, times 5, which is, again, 30. And then what's the only other number that's in the LCM that we didn't consider? So that's 30 times what is 90. And the only other number was the 3. The 3. So the 3 times these 3 numbers is going to give you, so this 3 times this number is going to give you your new number. So in this case, 3 times 30 is 90. So remember, if we're manipulating fractions, we want to manipulate them by a factor of 1. Because if I multiply something by 1, it stays the same, but it changes the look. Okay? So 3 times 23, well in this case 3 times 20, 60, right?
Yeah.
And 3 times 3,
9.
so 60 plus 9 is 69. Okay? So now we get to add the two equations, or the two fractions up. The LCM is going to help you a lot in trying to find the lowest common denominator. Okay? So it tells you, the LCM is the LCD, tells you what you're looking for. Now you just have to figure out how to get there. But then if you've done this already, it's a map. It's telling you how to get there. If you know that the two sides plus what's underneath it is this number, then I know that it's just going to be times 3. And the same thing here. It's going to be times the 5. And then it's like, it's real easy, it's real quick. And so now I've got these two numbers, and I just add them up. So I've got 9 and 5, which is 14, and 6 and 2 and 1, which is 9. Right? So now that equals, and this brings us to the next part is, wait a minute, I've got what's called an improper fraction now, right? I've got a fraction that's bigger on the top than it is on the bottom. So what do we do with that? And we just have to know that this number goes into this number however many times, and in this case it's 1. Yeah, you're dividing it into it. So how many 90s are there in 94? 1. With how many left over? 4 left over the 90. So whatever the bottom number is, it's just the bottom number goes into the top number how many times? With how many left over the bottom number. Every single time.
That's a quick way.
Quick way. If you keep that in your head, it'll work every time, right? But there's another problem. What's the problem now?
They're both, it can be simplified.
They can be simplified. They can be reduced.
Yeah.
Right? So, yeah, now, even though I've changed it from improper to proper, or what we call mixed fraction, it's still not totally proper because it can be reduced. So in this case, I need to find what? And I need to find, again, the GCF. The GCF. The GCF will tell me what number goes into both of these numbers. That's why we use these. Right? So if like you look at 4 and 90, what number goes into 4 and 90? Well, I know 2 does, right? Twice and 45 times. But does any number go into 2 and 45? No. So guess what? Wham! That's all it is. You just, by taking these two numbers and putting it into our little prime factorization, we were able to take and reduce our fraction right away. And it's what's left on the bottom. It's 1 and 2/45. Because 2 goes into 4 twice. And 2 goes into 90 45 times. And so what you'll find with these problems is that prime factorization is crucial. And this whole double number prime factorization that I'm showing you, how to find the GCF, how to find the LCM, is really crucial. Really crucial with fractions. We get to manipulate fractions really easily. Okay? So let's pause that and we'll look at something else on the test.
Can I copy that real quick?